In the previous video we talked about microcontrollers. Now let's go into a more subsection. What are the types of a microcontrollers? In this case, you can only focus on 8-bit, 16-bit, 32-bit. What type of microcontrollers you want, you can just take it out. Alright? And the numbers, I really don't know what the hell. This is the sales unit, how much they sell. In this case, 3366 is sold for the ARM system or the ARM system. But you need to know different applications for the 32-bit. Why? Because it's often being used. It's used for what? Parking, etc. All the intelligent purposes, right? Calculation, I don't know, but for really like this one, so many things. Ta-da! What is 32-bit? 32-bit means what? Base 2 to the power of 8. Base 2 to the power of 32. And if that's the case, then how much is it? It is 4 gig. Your 4 gig phone or your 4 gig storage data or whatever. Giga means that it is, because 2 to the power of 32 is 4 times 10 to the power of giga. I think it's 9, 10 to the power of 9 is giga. But byte, what is byte? Byte is 2 to the power of 8. 1 bit is equals to, 8 bit is equals to 1 byte. Okay, so 32-bit is equals to 4 byte. So 4 gigabyte, something like that of the meaning. What is hexadecimal? Imagine I have a 4-bit system, 1100. What is it all about? This is 2 to the power of 0, this is 2 to the power of 1, this is 2 to the power of 2, this is 2 to the power of 3. Alright, for example, if I 1111, this means that 2 to the power of 3 plus 2 to the power of 2 plus 2 to the power of 1 plus 2 to the power of 0 is what? It's 15. Okay? So to represent this 15, let's say I have many 4-bit, let's say I have 32-bit in this case, I will have 4 times 8 times of this one, so meaning 1100. I have all this is 32-bit. Then if you have to write 15, for example, 1100 is this one, 15. Then the rest, how do you do? Let's say there are actually maybe not 15, maybe like 12, 13, 1, 2, whatsoever. And if you write in terms of representing this thing, then this is actually a big chunk of numbers. Actually, don't follow this number. This number should be 15. Alright, 1100 should be for example, 1100 means it's 8 plus 4 means 12. Alright, if it's 1011 means 8 plus because this is 0 plus 2 plus 1. So 8 plus 2 plus 1 is what? 11. Something like that. Okay? But if you write it in terms of these numbers, it's very complicated. Therefore, what we do is to use hexadecimal. Hexadecimal represents 10 to A, 11 to B. So if let's say I have 15, then it's F. Why is 15? Because in a 4-bit system, the highest number is 15. That's why it's just maximum is F. So in this case, if it's 12, then I'll just represent this 12 as C. So instead of writing 12, I write C, something like that, and that's it. So example, what is this one? This one is 0 plus 2 to the power of 2 is what? 4. 2 to the power of 1 is what? 2. And then 2 to the power of 2 is, this is 0. So therefore, the total is 6. So I'm just writing this as 6. Okay? Now, what about 1110? This is 8, this is 4, this is 2. I sum it out, what is it? 8 plus 4 is 12, 14. 14. Instead of writing 14, I can write in terms of E. So this one is, I write it as E. Ta-da! In the previous video, we talked about all these peripheral over here. But I didn't touch on all of them. I didn't give the meanings. Now I'm going to give some of this meaning now, alright? For this meaning, it's being illustrated using 32-bit microprocessors. And we are using M3 ARM microcontroller. We are going to focus a lot of things on interrupts. Interrupts means what? For example, remember this washing machine, although it doesn't look like washing machine anymore. But imagine this is washing machine. Enter washing machine now. Alright? So this washing machine, for example, you are actually on the plug. And then it start to wash. And suddenly you know that, okay, shit, I forget to bring, I forget to take out my coils. And then you just walk here, you open it. You actually interrupted this system right here. It's washing happily, and then you open the door. If you open the door, it's still washing, then you are in danger. So therefore, always in the case, they always stop the system. And this is called interruption. Oh, we use RISC, handle interrupt, and it's good for embedded system. What the hell is that? I go to that one, what the hell is that? Let's talk about ARM processors. I forget to say, but it's something good to know. Alright, normally you have your particular chip. This is the number that it uses for this particular chip, and therefore it has meaning. AT has this meaning. Alright, SAM has this meaning for smart, and then S is for this smart, and then A is for ARM base, and then M is for microcontroller, and so on and so forth. I think you can see by the color itself, you can settle your own self, okay? If you don't know what the hell is RISC, you should just remember that it's something that is reduced instruction. It's somewhat reduced instruction, and why is it reduced instruction is good is because it is better, because it is more simpler, consume less power, and is faster. Alright, therefore it's dominant in embedded system because you want embedded system to be very small and process things in a more efficient way, and that's the meaning and reason why RISC CPU is good. I mean, yeah, 32-bit most likely you know, but one thing I don't know, 48 instruction, 48 clock cycle. Is it one instruction then one clock cycle? I don't know, I leave you to think about it. C friendly, this is talking about it is easy to code, and in fact why do you think that C friendly is over here? We are talking about the whole thing. We are not talking about is talking about the Cortex M3 ARM, the ARM microcontroller, and therefore these are the key features of this controller. So therefore the rest of this video will talk about all these key features. Next feature, advanced debugging. I think you know, because the system normally have a bug, so we need a debugger, something like that with coresight. I don't know what is that. What is good for debugger is because it set breakpoints. And therefore, what is breakpoints? To my best knowledge, it may run like this, A, B, C, or maybe it runs A and then run B and run C. If let's say you want to debug, for maybe B has a bug, and then you want to rerun this program A again, B again, and C again, but you're wasting time because you know A is good, C is good, but you're actually wasting your time to run A, then run B, then run C. Alright, and therefore this set breakpoints means that you can straight away break into this B and then analyze it, and then we run this B all again instead of running A, B, C all together again and again, waste time, right? I think this is to my best knowledge. Large memory address space, I think I no need to explain this. Interrupt handling, I think I talked about it already. Now, in order to handle interrupt handling, we normally use internal and external oscillator option. What is this all about? The oscillator itself is to reaction. It's somewhat like a reaction, whether you want fast or intermediate or slow reaction to the certain interruption. So I think so. I need you to go and check it out. Alright. The operations. Fast for normal operations, intermediate for fast start up. Slow is for backup mode, very low power. Internal quartz crystal for accuracy. Internal oscillator chip. I don't know what the hell. Accuracy 3%, very lousy, I think. Power saving backup mode means what? I have system A and system B. I only use system A and B is running. Then it's wasting energy, right? So therefore power saving backup means that if I run system A, I want system B to sleep so that I can save things. Alright, so lowest power consumption, and that's it. Voltage supply tolerance, it can allow a better voltage supply range. I don't know. Microcontroller can also sense a certain temperature, maybe used for other applications. Analog to digital converter, I think you know much, but it's talking about sensor. Alright, and that's it. ADC is indeed sensor because it changed analog to digital, and that's it. DAC, I think you know, digital to analog, and I don't know what the other way and what the hell. Swift modulation is something like that. You know that this is to convert digital back to analog. Digital is somewhat points. In order to connect points, you need to have certain modulation, and therefore in order to create a certain continuous analog system, and this is something of that meaning. Alright, for it's something like to control the analog device. From Wikipedia is for getting analog results with digital means. Alright, pins, I don't know what the hell are they, but I remember that 1 pin is equals to 2 bit. So if 144 pins, then 288 bits. I think so. General purpose I/O lines. So there is many purposes over here. It's switch triggers, meaning if you have a noise, something like that, you can actually switch trigger to apply it such that it becomes a more cleaner version of itself, something of that meaning. For is used to clean up noisy signals. Debouncing talks about certain keyboard something like, for example, if this is the one of the keyboard, like maybe this is A, and then you press, and then you keep pressing a lot of time. Alright, so this pressing a lot of time. For example, if you press 50 times and the program read 40 times, this means somewhat you lost 10 times, correct? But at least you read something. Alright, instead of you have maybe 35 or 30, something like that. So in terms of the noise due to your pressing on a certain stuff, I don't know what to say, but it is to clean, to make your input, alright, to be better defined, so to have less noise or something like that. Okay. This one I think you can read yourself, is to connect push buttons, make it easier. I don't know what the hell. This is some support, alright, external connectivity. This means that like USB and whatever. This is something I think you know much, alright. So it's just to connect externally, is a USB port or whatever, that's all. Next, timer. First thing, timing input. For example, if I input A, I input B. Alright, if I input A first, then I input B, then this will somewhat reflect that, okay, I input A, I input B. That means I input A first and then I input B. However, if I put input A and input B together, then my system should feedback that I input A and B together, something like, or A plus B, instead of A then B, something like that. So this is something of that meaning, I think. And frequency of the input is to calculate the frequency of the pulses produced when a wheel is rotating. For example, you have a certain sensor over here. I think this is something that I think you have a sensor over here, and this wheel is rotating. At this point, it rotates. It snaps a picture. Okay, stop. At this is point 1, and then it rotates again, and then this point reaches here again, point 2, and then rotates again, point 3. So this intervals is the frequency, how fast this point reaches the sensor point or something like that. Or in other words, how many times this point meets this line or something like that. Alright, this is rotating 1 time, 2 times, 3 times. So how many times or how fast it's going or something like that of the meaning. Okay. Where am I? Okay, wait. Timing processes means that if I have a process A doing certain things, how long does this process A do? If, like, for example, if I wash something in the washing machine, how long does the washing machine wash the clothes or something like that? 15 minutes, 60 minutes, yeah? Generating given frequencies. For example, if I tune a guitar, for example, if I strum the note A, alright, if I strum the note A, will this frequency be generated into the system or not? Is it sensitive enough? If I strum A minor, will it actually sense it also? So it will generate a given certain frequency, something like that, I think. Generating regular waveform with pulse width modulation. Ta-da! Example, go back to this one. If I have a digital signal I want to convert to an analog, I want to convert it smoothly and regularly in terms of certain so-called periods, I would say. So you want to so-called control the so-called the control of the analog system, so that you have a smoother analog output or something like that. So you somewhat control the power to the heater of a lamp. Alright, using this meaning of that. Alright, this is somewhat of a very abstract meaning, I would say. Timer is a 32-bit system, and yeah, it's equals to 4 GB if you still remember. Alright, so therefore you have somewhat looked into all these peripheral components. And what are these peripheral components come from? Coming from here, if you still remember, these are our core components, right? And then now we're talking about the peripheral things that may improve the core features in a way such that it's easier to control or more efficient to control and make things more nicer and things like that. Alright, now calculate battery lifetime. How to calculate milliampere? Okay, battery lifetime is always in terms of milliampere hours. Alright, and it's always supplied. For an alkaline AA cell or battery, is supplied roughly 2000 milliamp hertz. Alright, what is it talking about? Alright, it can supply either way 2000 milliamp in 1 hour, or it can also supply 1 milliamp in 2000 hours. So it's just simply milliamp times hours. So I have 2000 milliamp times 1 hour, I will have 2000 milliamp per hour. I mean 2000 milliamp hours, which is this one. So if I have 1 million amp times 2000 hours, then I will have this one. This is just a calculation. As for the rest, I don't think he actually go through, and therefore let's stop here. Good night.